Welcome to the video for simplifying expressions. When we simplify expressions, you learn to identify the like terms and highlight them using different colors to then combine our like terms. If there are parentheses, remember that we need to get rid of those parentheses first by multiplying before we can combine like terms. All right, let's look at an example together. Number 1, when I look here, I see 8x minus x minus 2x minus 5. Remember, we taught you to put a 1 anytime you see an x by itself because that means that there is one x. And in this case, because there's a negative in front, that means that it is a negative 1. So now I'm going to go through and highlight any like terms. So when I see the x, I can highlight all of the terms that have an x. So we have an 8x minus 1x and the negative 2x. These are all like terms. We can put them all together. And then I'm going to use a different color highlighter to highlight my other term, in this case the constant negative 5. And remember, we're always highlighting the sign in front so we know if it's positive or negative. Now that I've done my highlighting, I'm just going to put those together. So in my calculator, we can't put the variable, but we can put the coefficient. So 8 minus 1 minus 2 gives us 5. And they were all x's, that's why we put them together. So that's why I have a 5x. And then we have the negative 5. There are no other constants to combine with, so then I'm just going to put that minus 5 as the second part of my answer. And that's my final answer. So we can put a circle around it and give our answer 5x minus 5. Okay, so in number 2, I have more terms going on. So the first thing I'm going to do is, remember we also talked about standard form. And standard form is where we put those variables together and we go in alphabetical order. So in the first example, that's why I put the 5x before I put the minus 5. So when I look through to find like terms, I'm going to start by looking for x's because x comes before y, and that would any variables would come before a constant. So that's why when I look through here, I'm going to look for any x variables. The first one I see is that 1. I'm going to again put a 1 in there so I remember that that means there's one x. And then I'm going to highlight. So I have 1x with a positive that's in front of it to remind me it's a positive x, and then I have a minus 3x, so that's like a negative 3x, and that's it for my x variables. I'm going to switch highlighters before I put them together. I like to do all my highlighting and then put them all together so I can switch to the calculator. Either way would work. I forgot to put a 1 in there next to the y, so I'm going to sneak that in there as well. So now that I'm looking for my highlighting, I realize that that's a positive 1y, and then I have a positive 2y at the end. And then finally I see some constants that need to go together. The 15 that doesn't have a variable, that makes it a constant, and the minus 5 also a constant. Now that I've done my highlighting, we can go ahead and combine our like terms using our calculators. So again, I'm going back to that x first. 1 minus 3 gives me a negative 2x. Since it's the first term, I need to put that negative in front. Then I look at the y's. We had the 1 plus the 2. 1 plus 2 is 3, so plus 3y. And then finally the constant, the 15 minus 5 to give me the positive 10. So remember, that's something you can use your calculator for. Once we've done all the highlighting, we're looking for like terms, and we're going to put that in our calculator to figure out how many all together. So that's my final answer, negative 2x plus 3y plus 10. All right, let's look at another example. Okay, so now when I look at number 3, the first thing I notice is there are parentheses. So I have to ask myself, do I need to multiply? Well, if I wanted, I could put a 1 in front here. This just means there's a 1, 3x minus 5. And this is plus, so that's really just another 1, negative 2x plus 2. So multiplying by a positive 1 does not change anything. So I can just rewrite the terms outside of parentheses without changing any signs or anything because I'm just multiplying by a positive 1. So if you wanted to remind yourself, you could put the 1 in there. And that's just kind of to remind myself I'm just multiplying by a positive 1. So I'm going to rewrite 1 times 3x, and the negative 5 doesn't change anything again. So I'm just going to rewrite those outside of parentheses. Now that I am done with the parentheses, I'm going to look again just for like terms. So I have 3x and a negative 2x. Remember, I'm always looking for the variables first just to keep it in that standard form. That's why I do it this way. And then I usually do all my highlighting in one step. So then I'll do my -5 in the different color because it's a constant, and the +2 in a different color because it's a constant. And now I switch to the calculator. 3 minus 2 gives me 1x, or just plain old x. You could write it either way, 1x. -5 plus 2 is -3, so 1x minus 3 is my answer. Or again, you could write it as x minus 3. And then just remember to circle your answer. I wrote the other way as well just so you could see it. You do not have to do that, but I just want you to see both options. So 1x minus 3 is my answer. Let's look at number 4. Now, for number 4, if I sneak in my 1s again, in the first one, it's just a +1 out front. That won't change anything. But in the second set of parentheses, if I put a 1 here, this means that it's a -1. -1 will change things. So now this is where we have to draw that area model. So I'm just writing my terms on the area model. So the -1 is the one side by itself, and then I have the -7x minus 6 together, so that goes on the top, the -7x and the -6. To fill in the area model, we just multiply. So a -1 times a -7x gives me a 7x, and then the -1 times the -6 gives me a +6. So in the first one, the -3x plus 4, again, nothing changes there because it's just multiplied by a +1. But the second one did change to become a +7x and a +6. Now that I've taken care of my parentheses, I can go ahead and just look for like terms like we were before. X first, so I've got a -3x and a +7x. Switch my colors to then do the 4 and 6 in a different color because they are constants, no variable there. And then I can put together my like terms. So the -3 plus 7 is 4x, and then the 4 plus 6 gives me plus 10. So my final answer is the 4x plus 10. And that's the answer for number 4. Let's look at number 5. Okay, number 5 is just checking if we can use that distributed property. Now that's that same thing. We're going to use the area model to simplify this. So on the side, I'm going to put the 3 because that's the number by itself. And then on the top, next to that x, I'm going to put the 1x just to remind myself that that means there is 1x. And then above the other cell, I'm going to put the plus 4. Then we're going to go ahead and multiply to fill in our area models. So the first one, 3 times 1x. 3 times 1x gives me 3x. And then the 3 times the 4 gives me a +12. And that fills in my area model. Then I can write the answer from my area model, 3x plus 12. There's nothing else to combine, so that is my answer for using the distributive property to simplify. Number 6 is a similar concept. We're still going to need to use an area model to multiply the -4 times the -2x plus 8. So it'll look very similar. Area model, the -4 on the left, and the -2x plus 8 on the top. Then to fill it in, we multiply. -4 times the -2x. -4 times -2 is 8, times the x just gives us that 8x. And then the -4 times 8 gives us a -32. And that fills in the second cell. So now that I've used my area model, we can write it outside of the area model, 8x minus the 32. Nothing can be combined. There's no other terms to combine. So that is my answer for number 6, 8x minus 32. Okay, this last question says we need to write a linear expression in simplest form to represent the perimeter of a rectangle, the rectangle below. That's the first part of this question. So the first thing we need to do is just find the perimeter given these dimensions, 2n plus 4 and 3n minus 2. So before we do anything else, I'm going to start with that, writing that linear expression. Well, in order to do that, we have to know what perimeter means. So underneath perimeter, I want you to write add all the sides. That's what perimeter means. We need to add up all the sides. So if we look at this rectangle, I'm going to start by saying, okay, I'm going to add the side, the 3n minus 2. That's only one of the sides, though. Now I need to add the 2n plus 4, but that still isn't the full perimeter. I need to add the next two sides as well. So I need to repeat this by adding the 3n minus 2 again and adding the 2n plus 4 again. Now, I didn't use parentheses to separate the sides. You certainly could. So I added that above just so you could see it. The reason I chose not to the first time is that I can see the side, but nothing changes because there's no negative or anything that we need to distribute through. But this does help you see that it's 1, 2, 3, 4 different sides, and we can see the repeat in there. So if the parentheses help you, you can certainly add that step in there. And then, now that I have no more parentheses in the second step that I have now, I'm going to look for any like terms. So I have the 3n, the positive 2n, the positive 3n, the positive 2n. Those are all n's. Then I'm going to look back through and say, okay, well now I'm going to look for constants. So the negative 2, the positive 4, the negative 2, and the positive 4. Now it's a job for my calculator. I can type in all of the n's. So 3 plus 2 plus 3 plus 2 gives us 10n. And then the negative 2 plus 4 minus 2 plus 4 gives us plus 4. So that is my simplified expression, the 10n plus 4. That goes in the first blank, the simplified expression. So this is before I sub anything in. So the 10n plus 4, and we were talking about inches, so I'm going to put a label there so I know that that is the simplified expression. Now that I've simplified this, I can go ahead and find the actual perimeter using the second part of the question. The second part said, what is the actual perimeter if n equals 2? So now that I have a simplified version, the 10n plus 4, I can go ahead and sub in the 2 in place of n. So in purple, I wrote that underneath, the 10 times 2 plus 4. And then we can put that in our calculator, 10 times 2 plus 4, or you could do order of operations, 10 times 2 to get 20, and then add the 4. Either way, you'll get the actual perimeter of 24 inches. Again, using that label because they have it in the picture for us. All right, so that's it for this video, and now you're going to try the next page, the grasshopper page, for homework. Have a great night.